everyone, in this video I'm going to be talking about coordinate systems. This is actually part 2. In part 1 I just covered the basics. In this video I'm going to link what we talked about in the last video with these sorts of diagrams that you might see when we have these smooth lines. And the key here is really the distinction between continuous and discrete variables. In part 1, when we were plotting coordinate points, we were really only thinking about variables in discrete terms. So in this video, I'm going to be talking about continuous variables. And I think at one point in this course, in an earlier video, I did say I wasn't going to do this, but actually I think this is the best way to approach this issue. I'm going to start by talking about classifications of different types of numbers. And it is nice to know the classification anyway, so let's go ahead. I'm first going to think about a number line and I'll illustrate things there. And I'm going to start with our natural numbers, or sometimes we call them our counting numbers. These are the numbers you find in nature. So it's the numbers that we use to count things that we can actually see. So 1, 2, 3, ... etc. And hopefully you can see on my number line here that when I write out these numbers, there are gaps between our natural numbers when I write them out. Our whole numbers are all of the natural numbers plus 0. Our integers are going to be all of our whole numbers plus all the negatives of our whole numbers plus 0. Next, we have our rational numbers, and these are going to include any numbers that can be written as a ratio, so as a fraction. So these will include our integers because our integers can be written as a ratio, as being over 1, and heaps and heaps and heaps and heaps of other numbers in between. So 3 over 2, 7 over 8, 46 over 7, negative 100 over 10, you name it. And this will really fill in our number line here. You can imagine that most of the gaps between the numbers that I have labeled here will be filled with rational numbers. Most numbers can be written as a fraction. Now, lastly, I am going to add, however, our irrational numbers. These are our numbers that cannot be represented as a ratio. So things like pi, for instance, that's 3.14 ... are the square root of 2. These numbers are decimals that are non-terminating. So the decimals will go on forever. They cannot be written as fractions. They are irrational. And once we have our irrational numbers, plus our rational numbers, that will make our real number system, and that really fills up our line. Now, there are imaginary numbers and complex numbers too, but we don't need them. We are just going to stop here at our real numbers, which is composed of our rational plus our irrational numbers. And the real numbers will completely fill up our line. And so if we wanted to trace over all of our real numbers with a pen, I'm tracing over them now in green, they run into each other. So when we trace over our real numbers, we basically are just tracing over the line. We would not have to lift our pen up. And this feature of not having to lift our pen up as we trace over our real numbers, this is continuity. We say that the real numbers are continuous. All right, now let's rewind to what we said in one of our previous videos before about variables. We said that variables are measures that could take on different values, and we could think about economic variables that we might be interested in, such as GDP, price, quantity, cost, etc. And we use letters in our mathematics to represent variables. And we can use our algebra and our mathematics to model relationships between our variables. For instance, this is a demand function here, and this function relates quantity demanded to the price of a good. And the idea is that really in a lot of economics, we're going to model our variables as continuous. So we're basically saying that they can take on any number along that real number line. Now, we might impose some broad conditions on this. We might say that, and I spoke about this in the last video, we can't have negative prices and we can't have negative quantities. But, otherwise, if we model these variables as continuous, we're really allowing those price and quantity variables to take on any real value. And often this might seem like a weird condition when we think about it. For instance, if we think about the quantity of a good, we might not like it that our model includes situations where the quantity is equal to some decimal amount, so like 2.456 quantity or something like that. That seems weird. That doesn't happen in real life in lots of situations. You can't have a 2.5 of a refrigerator, for instance. And in lots of situations, we might think it's better to model quantity as just being, possible to have the natural numbers, and that would be a discrete treatment of that variable. But often these sorts of drawbacks are tolerated because when we do represent our variables as continuous, this makes available to us a lot of mathematics and a lot of analytical tools, which makes the study of relationships between our variables much easier. So we can work with algebraic functions without constraint, we can use calculus, we can draw relationships on our axes using smooth lines. And so often we do just assume that our variables are continuous, and it's a useful assumption to make, and really we don't see much drawback in making those assumptions. This means, though, however, that when we plot the relationship between our variables on our axes, let's, for instance, think about plotting a demand function on an axis. So I have price and quantity demanded. Well, here, if we say the quantity demanded is continuous, so it can take on any real number value, that means that all the possible quantities here will be associated with a price, which also can take on any real number. We're modeling it as continuous as well. And so when we draw out the relationship between these two variables, we're going to get a continuous line again. There's not going to be any gaps. So there will be no discrete jumps in our line. We get a smooth function here. And with these diagrams, we can be on the lookout for the same sorts of features that I discussed in the last video. So we see, for instance, that we have a downward orientation to our demand function here. We have a downward slope, we would say. So there is a negative relationship between price and quantity demanded. Now, before I finish the video, there is one last thing that I want to point out. If I remember correctly in high school, and I might not be remembering correctly, but I think it's still here, the logic when you read these diagrams was taught as, at least for me, we read across and down, across and down. I hope you can see my cursor making that across and down movement. Now, this is fine. We can read our diagrams this way. When we have demand, for instance, there is a natural interpretation of our points along our demand curve that has this orientation. So we could say something like, when the price is 4, we read across, and the quantity associated with that is 6. So when the price is 4, quantity is 6, across and down. I just wanted to note, though, often in economics, it might be useful to read our diagrams the other way too, and sometimes students aren't used to that. So I'll demonstrate. We might have, for instance, an axis where we look at how marginal cost changes as quantity changes, and we might ask, what's the marginal cost of the 8th unit? In which case we would look to number 8 on our horizontal axis. We would draw a line up and then across to see that marginal cost of the 8th unit is equal to about 4. So sometimes we read up and across. Now there is probably more stuff that I could say here, but I'm going to leave it here for now. That's our introduction to coordinate systems. In the next videos in this series, I'm going to be using these sort of axes more and more, and so we can get into the particulars there. I think in the next video, I'm going to teach you guys how to draw linear equations from the algebra. If you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can visit my store. The notes include lots of practice questions with solutions, which can help solidify your understanding of the skills and material discussed in these videos. Also, if these videos have helped, please like and subscribe, comment below, share, all of that. It all helps. Any feedback also is super welcome. I'm really hoping to make this course as useful as possible so we can get more people learning and succeeding at economics if that's what they want to do. Thank you so much for watching my stuff, everyone. Have a great day.